This time we will start column. We will do very basic of column. So first of all, what is column? Column is a comprehension member, but sometimes it takes moment, but mainly column is for comprehension member. So how column may fail? Column may fail in mainly two ways. One is material failure. You can see here, if my column is short and thick, and if I apply load, there will be some material failure, either by crashing or yielding somewhere inside the material. Other kind of column we call long column or slender column. A technical term is slender, SLENDER, or long column. If the column is long and the cross section is thin, then what will happen? If I apply load without material failure, the column may buckle. Buckle means sideways deflection. Hopefully you saw this kind of example in your real life many times. If you take a steel roller and apply compression, you will see that it will buckle sideways. So that is called buckling. So now when today our main topic is when the column will start buckling. So there is an equation developed by Leonard Euler. So Leonard Euler, he developed a equation which is called Euler equation. This equation has two forms. One is with load. Here P is Euler buckling load. Euler buckling load pi square E I minimum KL square. So what is E? Modulus of elasticity. What is I minimum? I minimum is moment of inertia, the minimum one. Why minimum? Because wherever or whatever the axis has lowest I, the beam the column will buckle in about that axis. So that is why we need I minimum. I will talk about this more. Okay, so what is KL? L means the length of the column. Why K? K is the called effective length factor. That means it will tell us the what is the portion of the column length will contribute to the buckling. That is called effective length factor. So I will discuss every item more. Okay, so next, if this equation is for load. Now if I divide this equation by cross sectional area, I'll get the stress, which is here. So PE Euler load by area. Then if I rearrange, my equation will be like this. So here I skip the derivation. So what is R? R means least radius of gyration or minimum radius of gyration. It is I minimum by A. As we are dividing by A, so we get A here. So this is the simplified and the polished equation. So Euler buckling equation has two forms. One is by load, one is by stress. So this is by stress, FE. It is very popular to use AP for steel design chapter or steel design topic. They use stress as F. So do not get confused between F and P. F means stress in steel design specification. So that is what and again, symbol doesn't matter as long as you understand. You can use your own symbol also. Okay, now why I minimum? That is another question. So if you can see here, I drew a column here. This is my column, and it is not square, it's rectangular. The reason is I wanted to make it different in both axes. So this is x-axis, this is y-axis. Now about which axis your moment of inertia is higher, or in other word, about which axis this column will buckle. So my common sense says, if my column is if my column is very long, no, it's not a good diagram, but hopefully you understood. So if I apply the load, what will happen? This column will buckle about this way. Why? Because the geometry, we have less material in this side to protect the buckling this way. But in this way it is very difficult to buckle because lot of material in this way geometry factor. So this is the common sense. In technically we say moment of inertia I. So whatever direction has I minimum, that is that axis is critical for column buckling. So here, if you consider this axis, your moment of inertia is b h cube by 12. If you consider this axis, b h cube by 12. Now the cube power, if I consider this part, it is huge. So I about this axis is huge, but I about y axis is less. So my iy is minimum here. By common sense, we can tell it. If you are not sure which axis is the critical or which axis has small, no problem. Determine moment of inertia about both axes and take the minimum one. This is why simply we can tell I minimum, or same. Then again, if you need R minimum, which is radius of gyration, take I minimum divided by area and square root. So hopefully I explain why I minimum, why we should take I minimum, because I minimum is the value about that axis the buckling will occur. That is why we take I minimum. Now K, what is the K? Now K accounts the variation due to the support restriction depending on the support type. So we will go, okay, before going there, here KL by R, this portion we call slenderness ratio. This is also a very good AP exam question. In AP exam, sometimes they ask what KL by R is known as what? It is known as slenderness ratio. That means the ratio of length to radius of gyration. That is called slenderness ratio. Now, oh, we are talking about K. Why K is important, or what is the purpose of K? So this column will show you different kinds of column with different no, not different kinds of column. Same is a single column, different kinds of support. Say for example, in this column, this support is a rigid fixed. That means this cannot rotate. This cannot move this way. This cannot move this way. It can take some moment. So this is called fixed support. This is also a fixed support. In this column it is fixed support, but it is not fixed. It's a pin. Pin means it can rotate. So you can see in this column, say here to here, this portion of the column is buckling. So K value is, and if we solve a differential equation, we can find that K value for this kind of column is 0.5, is theoretical K value. So it is not assumption, we can derive it mathematically. So for both in fixed, 50% of the length will contribute to buckling. So my K here is 0.5. Now in this handout, I also assumed here some recommended design value. We assume this one because to be safe. When we design something, we want to be safe. But again, design is not our consideration in this class. Design is we do it in a senior level class. Now why do we increase it? Because when we derive the differential equation, we made some simplification. This is why this is 0.5, but may not be 0.5. So to be safe, we use 0.65. Okay, so we will see, even it is same thing for all kinds of column. Okay, this column fixed here, pin here, and it cannot move this way. So for this kind of column is K is 0.70, and here design K value is 0.8. Okay, now how to identify? Oh, even more, I have more column here. Both ends are fixed. Here something exceptional. It is fixed. But what is happening? It can move. How it can move? If there I have more figure, more photo in my handout. I'll show you. But here the joint is rigid. That means it cannot take any. Sorry, it cannot rotate. But if the whole column deflect this way, then this support will deflect this way. In this column fixed here but free. There's nothing here, no restriction. Other column a pin here and fixed here, but it can move. When it can move, if my whole column moves, then the support will move. Okay, so for different cases, whatever your case is, hopefully you can come and pick your K value. In this column, in this topic, we should in this class is a basic class. you can use theoretical k-value or depending on the problem, but whatever problem you assume, that should not be a problem. So I will explain now how this can happen. Say category number D. What is this? Oh, in my here, if I see more, yes. So the elaboration of this meaning is given here. What is this? This is this category: rotation fixed, translation free. Translation means it can translate this way, but this cannot rotate. That means they cannot rotate. This is a rotation here, and here it cannot rotate. Every time this angle will be 90 degree, so it cannot rotate. Now when it is possible? To understand this, we need to know something more about frame. What is frame? Say this kind of frame, so one column, one beam or girder, other column. These two are bracing. These two are bracing to resist the lateral load. If there is a bracing, this joint cannot move this way. Even this column cannot move this way. It may buckle here, but this joint will be here. Same thing here. But if my joint is rigid and fixed here, so this category we call rigid fixed. So this category is A, category number A. If you see category number D, what is this? Yes, fixed here, rigid here, but there is no bracing. There is no bracing. If there is no bracing, this whole column can move this way. That is called sway. Sway. So the elaboration of this column is fixed, side sway, non-inhibited. Non-inhibited means it is not protected from lateral translation. So fixed here, rigid here, but it can have sway. Sway means it can move laterally. So this is that category. Fixed here, it is rigid, but it can have sway. Okay, another important thing is to tell you that most of the column in our real life is pin. We assume pin, although it is not pin, but we assume it is pin to be safe, and that is the safest consideration. But if you know exactly in your exam, if the problem makes it difficult, like say that one end of the column is pin, other end of the column is rigid but non-inhibited. So pin, other in column is rigid but side sway non-inhibited. That means this category. So whatever this category is, hopefully you can find your K. Okay, so if I go back again, so this is the Euler Buckling stress equation. Everything is clear. E is the modulus of elasticity, L is the total length, K is the effective length factor depending on the support condition, R minimum is the least radius of gyration. Now in terms of load, it is this equation, pi square E I minimum. Why I minimum I discuss, because I minimum I minimum is the value of moment of inertia about an axis which is vulnerable. Okay, so let us see. Or now if you read this text, hopefully you can identify different kinds of column. So here is another example, pin here, but this is rigid but side sway non-inhibited. That means it can move this way. So it's case number A. Okay, so let us see some example very quickly. For this problem, what is the Euler buckling stress for 12-meter column with both ends fixed? Both in fixed means K is 0.5. I gave here so that it's easy for you at the beginning. E is given to the 210 gigapascal, radius of gyration is 10. Now they did not tell minimum. That means it should be a square or circular column, so that we know that both way it is same radius. So what is the equation? It is stress pi square equal by r minimum square. I did not write here minimum, but it is the minimum because I did not write because in this column both way it is same. So pi square E should be Pascal, Newton per meter square, meter. So my units are consistent. Okay, so if I go back, this meter will cancel because it is the ratio L by R. So ratio, then my unit will be in Pascal, and I converted to mega. 10 to the power 6 means mega so megapascal. Other equation example is this equation. This is my column length is 12 feet, the cross section 8 inch here. This way E is given, uh, both pin supported at the both ends. That means K is on. And I told you most of the column K is on. But what is the I? You should consider 8 12 cube by 12 or 12 h cube by 12. That means Ix or Iy. You always the minimum one. So Ix is 8 12 cube by 12, Iy is 12 8 cube by 12. So this is the minimum. We'll consider this one. Then we found the R minimum, I by A, then square root, we got the R minimum. Then my by Euler Buckling stress equation, pi square E KL by R minimum. Everything is known. Common mistake people do here. Your R you are getting is in inches. The length is given in feet. So make sure you are careful about your L. It should be same unit of R, same unit of R, so that it will cancel whatever the unit of E, that is the unit of the answer. And stress means force per unit, force per area square, force over unit of area square. So it is KSI, or if you make this consistent, same unit, whatever unit of E, that is the unit of this. So do not make mistake here. And again it is I minimum, and L by R should have same unit. Okay, so we covered in this chapter, is very short chapter, is what is the Euler buckling load and what is the Euler buckling stress. So what is this? It is the load or stress at which column will start buckling. We do not want column to buckle. Why? Because then we cannot use the material properties. Its failure is by geometry. We try to avoid this. So how to find it? This is the equation. We need I minimum and K. K is critical, and for stress equation we need R minimum. So every time I minimum or R minimum, we need least moment of inertia was least radius of gyration. Number 2 is the K, which is effective length factor. How to find it? Depending on the support condition, you can pick your value. If the problem does not tell you design or theoretical, better to use theoretical. Better to use theoretical value, because in this class we are not doing any design. In senior level class, 400 level class, if you design it, then you can take this value in your design class or design time. Now it is your analysis time. Whatever it is, the problem will tell you. So now how to find the type which we are looking for? Simply consider the support type and see whether it can have sway or no. In this way you can find it. So okay, I will wrap up here. Hopefully you understood. You can read this handout, or even you can read your other books, online videos, whatever. So I will wrap up here. Thank you.